Okay, so this is kind of cool. I've learned how to design and have manufactured custom printed circuit boards. So here's my first one. Okay, so let me zoom in a little bit. So here's my first custom printed circuit board. It's an oscillator, and I'll run it in a minute. But this shows the top side of the board, and then here's the bottom side of the board. And if you look closely, you can see the copper traces on it. Okay, so let me turn the thing on here and I'll have it run. So what it is, it has a integrated circuit chip called a 555 timer, and then outboard from that are some capacitors and resistors, and you can see a couple of LEDs flashing here. So the board is a little bit bigger than a postage stamp, and I had them made at a shop down in Oregon called Osh Park, and what they do is they charge $5 per square inch for a minimum quantity of 3 boards. All right, so I have 3 of these things, right? You can see all 3 of them here. So it's pretty cool that it's now possible to have custom printed circuit boards created at a pretty reasonable price. And the way that I did it is I use a software tool called Eagle to design the printed circuit board. I'm running the free version. There's another version, a professional version that's available, I think for about $70. But it's basically a 2-step process. The first step is to create a schematic, and the second step is to create the layout of the printed circuit board. So what you do when you create the schematic is you select your components, and then there are libraries of different kinds of components, and they kind of divide it up into 2 basic categories. One is through hole, and the second is surface mount. So this one that I did here is all through hole components because that's what I have, and they're easier to work with. Now that I know this thing works, I'm going to make another version of it with surface mount components, and I can make it smaller, maybe 50% smaller, depending on how it lays out, and I'll show you that when I get there. But basically what I've got here in the center is a 555 timer chip, and then you can see there's some LEDs and resistors and capacitors. And so this establishes the logic of the circuit. Then over here is the physical arrangement of the components. So what you do is you create the schematic, you pick all the footprints, and then you lay out the board and you establish the periphery. And then there's a trace routing routine that runs that will route all the copper traces. So in this view, the red ones are on the top side of the board, and the blue traces are on the bottom side of the board. And you can see, like down the lower left there, you can add text. So one of the things I do is I add text to everything here that shows what the name of the component is and its value. So for example, in the upper left there, it says a 9-volt battery, and I label the positive and negative sides of it. You can see over on the right, I've got the value of the resistors, 220 ohm resistors. Up in the center on the top, there's a 470 ohm resistor. There's a 1K resistor. Okay, so I label values of everything. And then what you do when you get all done is all you have to do is upload to the website for the company that makes these things, this board design here. So there's a company down in Oregon named Osh Park, and they do custom manufacturing of printed circuit boards. And what they do is they collect circuit board designs from customers, and they put them together into one larger board, and then they send it out for fabrication, and they're partitioned. And what they do is they manufacture the board, and from the time you order it till the time you get it in your mailbox is just 12 days. And so What happens when you upload your design to the to their website, they can generate all the files that they need. So here's my board, and it has a bunch of different views of it. So here's the top of the board as if you were holding it. Here's the bottom of the board down here. Or as part of the manufacturing process, there's a drilling routine that it runs. Here's the bottom copper traces. Here's the top copper traces. Here's the outline of the board. Now this one is rectangular, but if you want to make it, some weird shape, like you may have seen things that are like at Christmas time. You can make boards, you can buy boards or whatever. They're shaped like a Christmas tree and have blinking lights on them. So you can do stuff like that. And so there's in Eagle, there's a polygon editor that you can make for the board outline. Here's a solder mask, and all the solder mask does is make sure that your components, when you solder them together, that they don't have bridging between them. Here's the bottom solder mask. Here's the top solder mask. The silk screen is the printing that's on top. So it's a pretty cool thing. So it's very interesting to me that a couple things have happened in the last few years that are pretty cool. This one, obviously, where you can have custom printed circuit boards designed for a very affordable cost. So I got 3 of these for $6, so they're $2 a piece. And then if you combine that with 3D printing, where you just go into a CAD editor and create packaging, so you can create, highly customized designs of whatever you want to do, and it's all really affordable and gives, really professional quality results. So I'm kind of excited that I've figured out how to do this. I've learned the software, found the shops that do it. Learn how to use the libraries and some of the techniques. I'm not an expert by any means, but I at least have some initial kind of primitive capabilities to do these kind of things. All right, so here we go. Custom printed circuit boards.